Welcome to my YouTube channel Mechanical Magic Mechanical Learning Tutorials. Today we will discussing with the constant temperature process, or you can say the isothermal or hyperbolic process. So let us start with the some of the non-flow processes. So in non-flow process it will be representing as in which there is no mass interaction across the system boundaries during the occurrence of the process. So there are a number of non-flow processes. So first one is the constant volume process, or you can say the isochoric process. Second one, constant pressure process, or you can say the isobaric process. Constant temperature process, or you can say the isothermal process. So today we will only focusing on to the constant temperature process or isothermal process. Then one more, adiabatic process, in which there is no heat transfer. 5 number, the polytropic processes. So let us start the constant temperature process, or you can say the isothermal or hyperbolic process. So generally in the constant thermal process, when a gas is heated or cooled in a piston cylinder assembly, keeping W weight such that the temperature remains constant, then the process is called as a constant temperature or isothermal or hyperbolic process. So let's see on to the PV diagram. X-axis representing the volume and y-axis representing as a pressure. So in which state number 1 or point number 1, P1, V1, and just it will be changing from one state to another state at constant temperature. So that will be P2, V2 at point number 2. So that will be equal to PV equal to constants, and it will be nothing but it will be said to be a Boyle's law. So in the case of Boyle's law, T1 equal to T2, that means constant temperature process. In that case, value of the index that will be equal to 1. So during this process, the gas receives the heat and converts completely into the works. So during this process, temperature remains constant, and hence the change in internal energy becomes 0. So work is done during expansion and required for the compression process. So relation between PV and T, P1 V1 upon T1 equal to P2 V2 upon T2. In that case of constant temperature, T1 equal to T2, that means PV equal to P1 V1 equal to P2 V2, and that will be nothing but representing as a Boyle's law. So work done in the case of constant temperature process, 1 to 2 process, P into dV, but P1 V1 equal to PV equal to constant. So P equal to constant upon V. So let's put the value of the P into equations. So for 1 to 2 process, C by V into dV. Then C into 1 to 2 process, 1 by V into dV. So P1 V1 1 to 2 process, 1 by V, that will be into dV. So P1 V1 finally log of E V 1 to 2 process. So finally work done, P1 V1 log E V2 by V1, that will be representing over here for the constant temperature process. So V2 by V1 equal to P1 by P2. So at constant temperature, change in internal energy, that will be du equal to u2 minus u1, and that will be equal to 1 to 2 process mcv delta t. So du that will be equal to mcv t2 minus t1 kilojoule. But for isothermal process, t1 equal to t2, that means du equal to 0. So there is no internal energy stored into systems. Now we will discussing with the change into enthalpy. So dH equal to mCp T2 minus T1, that will be the similar isothermal process, T2 equal to T1. So dH equal to 0. So that means change in enthalpy of the system at constant temperature, it will be 0. Next, heat transfer. So as for the first law of the thermodynamics, del Q equal to del W plus du. That means heat supplied equal to work done plus stored energy. So here du equal to 0 because at constant temperature process. So dq equal to dw. That means what? Heat supplied on the systems, it will be 100% converting into work done. So del q equal to P1 V1 log of E V2 by V1, or you can say del q equal to mR T1 log of E V2 by V1. So that all the relations of at the constant temperature process. If you like it, subscribe, like and share Mechanical Magic Mechanical Learning Tutorials.